Welcome to ICSE Computer Application Class 8. In this channel, we will be discussing all those topics which are prescribed by the ICSE board for Class 8 students. I am Ganga Devi and this is my second channel. My first channel is ICSE Computer Application Class 10 100 marks and the link is given below. If you have brothers and sisters who are studying in class 9 and 10 ICSE board, please ask them to go and visit the channel and they can get all the notes and all the details of class 9 and 10 topics in detail. And in this channel, we are going to start with the first chapter prescribed by the ICSE board. The first chapter is Operating Systems and Graphical Interface, Roles and Function. So we can see each topic in detail. In the end, if you like the video and understand the concept, please don't forget to press the like button and write your comments. And please subscribe my channel so that all the upcoming videos you will get whenever I am publishing that system. First of all, we can see what is the definition of a computer. Computer is an electronic device which performs a specific task according to the instructions. We as the programmer or we as the user, we are giving the instruction to computer either by clicking the mouse for the particular application, otherwise by writing the program we are giving the instruction, and computer is the electronic device which performs the specific task according to the instruction given by us. And in computer, hardware and software are there. Computer is divided into hardware and software. Now we can see the definitions of hardware and software. Hardware is the physical part of a computer. The physical part which we can see and touch. Example, here we can see the monitor, keyboard, all these things. Whatever things are here, whatever we can see and touch in computer, it is the hardware. And software are the programs in the computer. It is a sequence of instructions used to solve the particular program. Now coming to software, we are having two types of software, that is system software and application software. We can see the definition of these two in the next slide. So now system software have operating system, utility software, device drivers and language processor. While application software, based on the applications, we are having many applications, for example, word processing software and presentation software. So before going into detail, first of all, we can see the definition of system software and application software. System software is the type of computer program that is designed to run a computer's hardware and application program. That means for enabling the computer to work properly, we must have the system software. In this, operating system is also there. Without the operating system and without the system software, the computer will not be able to work properly even if all the hardwares and other application programs are there. So system software must be there for the smooth running of the computer, and it enables the application program to run smoothly. And here we can see the examples. Operating system, it is a system software. Language processor, utility software, and language software and device drivers. So all these are examples of system software. Now coming to application software, it is the set of programs that is used to perform the specific task like creating an Excel sheet, making a presentation, typing in Word, creating photos. We can use Photoshop is there, painting, paintbrush, starting from paintbrush, many softwares are there. So for the particular application, if we are using a program or a software, it is known as the application software. For example, MS Word, mainly for the typing purpose we are using, PowerPoint, making presentation, Photoshop. We can beautify the picture, we can arrange the picture, we can change the color. So many things can be done in Photoshop, paintbrush and Corel Draw. So for a particular application, we are using the application software, while System software is the basic one which is used for starting the computer, for booting the computer, and for enabling all the functionalities in the computer. Now one by one we can see the different types of system software. First of all, utility software. It is the software that performs a specific task mainly related to the management of the computer. So various utilities are there. Otherwise we can say various activities like keep the backup data, clean the memory, remove outdated files. So all these functions are done with the help of the utility program or utility software. So for this some example we can see antivirus software. It will protect, and text editor for editing. Compression utility, we can compress a big file into small one by the compressing software, and backup program. So all these are example of utility. Now language translator. As you know already, computer can only understand the binary language, that is 0 and 1. And it is difficult for the programmers to write the program in binary language because the combination is very lengthy and it is different for each operating system. So what we do, we will write the programs. We can write the programs in BASIC, we can write the programs in Java, we can give the instruction by clicking or typing. So whatever instructions or programming lines we are writing, how can the computer understand? So for this we are using the language translator. The language translator translate the source program or the instructions which we are giving into binary language, or we can say object code, that is 0 and 1. So by then the computer can understand the binary language and the function or the work will be done. And we are having the language translator. Compilers are there, interpreters are there, assemblers are there. So assemblers were used early. So now interpreters and compilers, I think we have done this in the smaller classes. So these compilers and interpreters compile or interpret the source program which we are writing into object program, otherwise we can say binary language. So now what is the difference between the compiler and interpreter? Both of them will convert the source program into binary language. In interpreter, for example, if we are writing a program, just think we are writing a program in interpreter, line by line checking will be done. And if there is a mistake in the first line of the code, the program or the application will stop there. And unless we correct the mistake, it will not go to the next one. And then the next line will be checked. If there is no mistake, third line, whenever a mistake is coming, it will stop and we have to check the mistake and correct it, and then it will be compiled. And in compiler, the program or the application will be compiled all together and the mistakes will be shown together, not one by one. So together we can correct the mistake and then the application will be running. So language translators are used to convert the source code or the instructions which we are giving into object code so that the computer can understand. Coming to operating system, it is the interface between the user and the computer, and it acts as a platform for the computer hardware and software. So for understanding this, we can take example of TV. All of you have TV at home and all of you have the cable connection or dish antenna connection. If there is no cable connection or dish antenna connection, will the TV works? The TV will start, but no functions, no channels will be coming because this TV connection is not there, and otherwise we can say cable connection is not there. Now take the example of computer. You have a computer, the best computer you are having. But if you are not having the operating system, the computer will not work. So operating system is the most essential part of the computer. Example, we can say mobile application also. We are having the Android, iPhone you are having. So one operating system will be there. And without the operating system, your computer, your mobiles will not work properly. Operating system manages and control all software and hardware operations. So we can see what is the need of an operating system. Operating system, first of all, it coordinates the activities of software and hardware. Without the operating system, your instrument will not be working. And operating system decides all the operations of computer, including what to do, what work to do, when to do, and how to do. It manages the hardware and software functions, and without the operating system you will not be able to do any work in the computer, and it is the main link through which we can interact with the computer. So if we are discussing what is the most important part, essential part of the software, we can say it is operating system, because without that you will not be able to interact with your computer. Without the operating system we will not be able to open Word, we will not be able to open PowerPoint. In mobile, if Android is not there, we will not be able to go to, we can say, any app, Play Store or any app. So operating system must be there in the computer, otherwise we can say in mobile. Coming to functions of the operating system, the functions are processor management, memory management, file management, device management, security and protection, job management, and command interpretation. So one by one we can see in detail what are these different types of functions which are done by the operating system. The processor management creates and deletes process. That means the work done by the computer. It schedules the whole work going in computer. It allocates and deallocates processor to a process. So here the work, it is arranged in order, and which work to do first and which work we have to do second. So all the processing is arranged by the processor management in operating system. Memory management deals with the allocation and deallocations of memory for each process or programs. So memory we can define as the speed of the computer also. So when a work is done, that means when inputting and outputting is done, the buffer memory is allocated, and after completing the memory will be released, and for the new work memory will be given. So whenever a work is coming, the memory will be allocated by using the memory management system, and then when the work is completed, that much memory is relieved so that this memory can be used for any other process. So all these things are managed by the memory management system, and it decides the amount of memory needed for each process. For each work, how much memory we have to. Coming to file management, we know computer use a lots of files and folders. That means whenever we are saving something, saving a file, we will save it either in the primary memory or secondary memory, and folders are created. So file management system keep tracks of all different files and folders that are created and stored, and it keep us or help us to organize this data in files and folders, and all the file related activity. For example, we will name a file while creating in MS-DOS. Also we can create a file, and GUI system we can create the folder, we can create whatever files we want. So all the creation of the file, naming the file, deleting a file, so whatever work is related to file management, it is done in this system. Device management. Device drivers control the activities of a particular type of device connected to a computer. So first of all, when we install the operating system, for example, if we don't install the sound card, it will not use. That means we cannot hear a sound and no sounds will be recorded. You may have seen when we are buying a printer, and if we are trying to connect the printer to the system, we have to install the driver, print driver. That means whatever driver is coming along with the printer, we have to install. So all the input and output device, it is installed and connected to the computer, and allocation and deallocation of all the devices is done by the device management. So in one word we can say all the device connected to computers are managed by the device management. Here, operating in the operating system, security and management system make sure that only authorized users get access to the computer, and its data, and the users only do things they are authorized to do. For example, if you have given a password to computer, without the particular password type, you cannot open the computer. Antivirus software, firewall, face detection, monitoring, identity, so many things are there for protecting the computer. So the operating system will make sure only those who are having the correct password or face detection, we can say, and if the antivirus is installed, the virus is not there. So all these things are done by the security and management system, and it will make sure, suppose if we are giving some permission, the user will only do whatever it is permitted. So the security part is done by the security and management system in operating system. Now, by using the job control language, that is JCL, the user can communicate with the operating system and tell it what to do. So many different jobs are there: printing a file, saving a file, typing. So all the different kinds of jobs are managed by the job control system. It will keep track of various jobs and users working in the operating system. Otherwise, we can say computer. And it is the process of allocating system resources, that means memory and all the things, allocating the system resources to many different tasks by the operating system. And it also decides the priority of job, that means which job we have to do first and which job we have to do second. Command interpretation. Command interpreter is the part of the computer operating system that understand and execute the commands that are entered indirectly by a human being or a program. Here we can see the commands are there and they are executed, and these are entered by the programmer, and command interpreter will understand and execute the particular command. And in some operating system, the command interpreter is also known as the shell, and this is the command.com file. Now we can see what are the different types of operating system. First one is single user operating system, multi-user operating system, multiprocessing operating system, multiprogramming operating system, real-time operating system, and distributed operating system. So various types of operating system also we have to learn in chapter 1. In single user operating system, only one user can work at a single operating system, otherwise single computer, and at one time only one task can be done in the single user operating system. For example, we can have MS-DOS. In multi-user operating system, as the name indicates, multiple users can connect to the CPU, otherwise central processor, by different terminals, and at the same time they can do different kinds of work. And users on the system are connected by the network. Example is Linux and Unix. So more than one person can work at the same time, and more than one work can be done at the same time by using a multi-user operating system. Now coming to multi-programming operating system. It has the ability to execute multiple programs with only one processor or machine. Here we can see in RAM so many processes or so many works are there. Add to number, print the number, save the number. So many works are there, and multiple process or multiple works can be done, or multiple programs can be executed in the multi-programming operating system. So these processes one by one it will be sent to the CPU and the process will be executed. So in this case, the CPU will take the first process, complete the work, then only will go to the second process, and after completing second process it will go to the third process. So the last process has to wait till all other process is completed. And in between, if one process has to go, that means for example the first process add two numbers, so it has to go to input area for getting the two numbers. At that time the second process will be taken by the CPU. So you can understand better with this example. Suppose one teacher is there and students are there in the class, and the teacher has given 10 questions to each student to complete. So they need teacher's help. So the teacher will go to the first student, help him or her to complete the work. After completing it, she will go to the second student. And after completing her work, she will go to the third and then to the fourth. So the last one has to wait till all other works are completed. In between, if one child want to go to washroom or want to drink water, so the teacher will leave their students and go to the next student. For example, the second student is going to washroom. So after completing the first process, the teacher will go to the third process because the second process is going for some other work. So in multi-programming, more programs will be worked and each program will be completed before going to the second program. Now, multitasking operating system. First of all, we can see what is multitasking, and then we can see the difference between the multitasking and multi-programming. So, multitasking we can also say as time sharing. Time sharing operating system has ability to execute more than one program at the same time. So here for each process, time limit will be there. It will be allocated a time. One part of the first process will be completed. It will not complete the complete process. One part of the first process will be completed. Then it will go to the second process. One part of this will be completed. Then third, fourth. That means part by part the work will be completed. And then after completing the last one, then again it will come to process 1. Here we can understand better with this example. As we have told, the teacher is giving 10 questions for each student. So in this case, what she will do, she will go to the first student, solve her 2 questions, then will go to the second student, solve the 2 questions, then third and then fourth. And after solving 2 questions from the last one, she will again come to the first student for solving the next 2 questions. In this way, all the process will be engaged. Otherwise, we can say all students will be engaged and they will be doing the work simultaneously. So that is the difference. Multi-programming, only after completing one process, it will go to the next process. But in multitasking, part by part, that means part of the program or process will be completed and then once again it will be done. That means repeated. First 2 questions again, then the next 2 questions, then again 2 questions, and once again it will come to the first child. So in this way all students will be engaged. Otherwise all process will be worked together. So here we can see the response time is less because only after completing one work with the CPU, here in this case multi-programming, the response time is less because only after completing one work it will go to the second one. So response time is last one has to wait for more time. But in multitasking, part by part will be working so that all work will be done simultaneously. So this is the difference between multitasking and multi-programming. We can also call multitasking as time share. Multiprocessing operating system, in this 2 or more central processing unit, otherwise CPU, will be used. That means it will be within a single computer system and these multiple CPUs are in close communication. They will share the computer memory, we can share it, and other peripheral devices just like printer. So the peripheral devices can be shared and memory of the computer will be shared equally. So the work will be done fastly. So for understanding the multiprocessing means more than one processor. Otherwise we can say CPU will be there inside the computer and it will make the computer work faster. So we can understand with the help of one example. So here all of you are in class 8 now. Suppose just think we are having 3 sections. So in this, suppose if the principal is telling the class teacher, do take the exams, we can say unit test, take the unit test for each class, and if no other teacher is there, only one teacher is there, that means in for example processing, in that case only one CPU. So what will she do? She has to go to the first class, for example 8A, take the test, then she will go to the second section 8B, and then she will go to the third section. This will take a lot of time. So now what we can do, how we can speed up? So the principal can send 3 teachers, that means each teacher to each section. So in this way the work will be done fastly and time limit, that means within a given time we can complete the work. So CPU is also doing the same thing. If only one CPU is there, maybe it will take a little more time, but multiple CPUs will make the work easier and make the computer speed Very good. So this is known as multiprocessing, more than one processor at the same time. Multiprocessors, we have seen Intel processor, quad processor, like that. And now coming to multi-threading operating system, this operating system will allow the different parts of a software program to run simultaneously. So in one program, it will be divided into different parts, and all the parts of the software program, it will run simultaneously, and this will make the program run fast. For example, if you connect a gaming system to your computer, your friends can use the different parts of the same game. They can play the same game. For example, one can use the mouse to play, one can use the keyboard to play the same game, and one can use a controller, any game controller, to play the game. So simultaneously, many people can play the game in the computer or by connecting the remote, etc. So this is known as multi-threading operating system. The different parts of the software program will run simultaneously. So example of this is Windows XP and Windows 7. Distributed operating system. As the name say, the operating system is distributed. The work is distributed in various operating systems, otherwise we can say computer. It allows the shared data work to be accessed from any machine on the network. It will be connected, the network will be there, and computers or operating system will be connected to the network, and each computer has its own memory but situated in different places. And server controls the interconnected computers and make them appear on the single computer. So the work will be distributed and work will be done in various computers, and server will be controlling them, and we can send the work to the server so that it appears on the single computer. And if geographically connected, one computer is not working, for example, this computer is not working, then that part of the work which this computer is supposed to do can be given to the other computer, so that the work will not be stopped and work will be completed in time. Now students, coming to real-time operating system. This operating system is intended to serve at the real time. That means as soon as the data is coming in, the processing will be done. Some small example we can take. For example, ATM machine. You are going to ATM, you are giving the pin, entering the pin, execution will be done, and at the same time, if the balance is there, you will get the amount. Suppose we are having live YouTube. You are watching this video in YouTube. At this time it is not live. Just think we are having the live session. So while we are discussing, you can also give the comments. You can also ask your doubts at the same time. I can reply. Microsoft Teams. Your teachers are teaching in Google Teams. They are teaching now. So when they are teaching at the same time, you can see and hear and understand. So that is the real time. That means as soon as the data is coming in, it will process and give the result. And processing time are measured in tenths of second. That means very, very small or shorter increments of time. Reservation system. You are reserving ticket for flight or train. You log in, and as you log in, you can see the number of seats available. You can book the ticket, and as soon as you book, that particular seat will be coming as non-available because you have booked. So these all things are real time. We are giving the data, at the same time the result is coming. And real-time operating system also, it is divided into two: hard real-time and soft real-time. So we can see what is the difference between the hard real-time and soft real-time. The hard real-time system guarantees that critical tasks complete on time. That means not even delay for tenths of second. At the same time, as soon as it coming, we have to complete that. This goal requires that all delays in the system be bounded from the retrieval of the stored data to the time it takes in operating system. That means not even 1/10 of second delay. We have to handle it as soon as the data comes. We have to complete the work. For example, we are having the missile system. If the missile is intended to go for a particular place and some problem comes, and if you don't do, that means execute the problem and find out the problem and execute it and make it correct, the missile can go somewhere else. It can damage. That means it will do what is not it is intended to do. So we cannot delay. As soon as the mistake is coming, we have to correct it. So this is known as hard real time. Not even 1/10 of a second delay should be there. And in short real time, we can have some seconds. That means, for example, we are having the gaming. we are playing the game, even if 1 or 2 seconds delay will not affect. Okay, we are doing in real time, but 1 or 2 second delay will not affect the gaming. And example, I have given a YouTube video. Even if the live session, if I am talking and if you are hearing after 1 or 2 seconds or even after 1 minute, it will not cause any problem. So this can term as a soft real system. Now coming to interface. Interface is the platform where two systems interact with each other. An operating system acts as the interface through which the user gives the command to the computer and also receive the message from the computer. Just think, you are having a computer and no operating system. You will not be able to do any work in the computer. So we must be having, that means we must have an operating system, then only we can give the commands to the computer, and then the computer after doing it can send us the message. And two types of interfaces are there: character user interface, that is CUI, and graphical user interface, that is GUI. So here, as you can see, in graphical user interface, nowadays all of us know we are working in Windows, so all of us are compatible with this. So here by using the mouse, we can give the commands, we can do multiple programs. That means so many programs can be done, so many applications can be done at the same time. So here by clicking, no need of remembering the commands, just by clicking the mouse, with the mouse we can have the work done. But in character user interface, mouse will not work here. So here we have to type each command, whatever command you have to do. MS-DOS is an example. So here, and Unix, so we have to type the commands, then only it will be working. Now we can see the difference between graphical user interface and character user interface. Graphical user interface, it is easy to learn. We can use the mouse. We can just click and do a particular work. But in character user interface, we have to learn the command, so it is not easy to learn. And in graphical user interface, many applications can run at the same time. And in character user interface, only one application can run at one time. And graphical user interface, as we are using mouse, there is no need to remember the commands. But character user interface, we have to remember the commands. If the command is not correct, the work will not be done. So with this, we come to an end in this video. I hope all of you have understood the concept. What is an operating system? What are the different types of operating system? What is the need of an operating system? And what is interface? Two types of interface. So if you understood the concept and if you like the video, please don't forget to press the like button. And those who haven't subscribed my channel, please subscribe it. And we can see you all in the next video, in which we will discuss the functions and formulas in Excel. That is chapter 2.